It's Dale again from VIA Technologies, and in today's project I'll be showing you guys how to create an object tracking device guided by color recognition. Here's a few items we're going to be using: a VIA Pixetto vision sensor attached to a camera bracket, an Arduino board, an expansion board, 2 servo motors, 2 very tiny screws, 2 brackets for the servo motors, a micro USB cable, and a groove cable. The object tracking device will move itself around to follow and track and detect the object. Since I've already introduced you guys to the items, let's get into step 1.
So here we're at step 1, assembling all the components and parts. We need to put together all the components and parts to build the object tracking device. Let's get started and put these all together. Cool guys, here we are at putting all the components together. So the first thing I'm gonna do is I'm gonna install the first servo motor into the lower servo bracket. And I'll be using a screwdriver to insert it in the hole, and then I'll gently pull out the cable. Then I'll make sure that the motor is secured at the base carefully, as you see that I'm doing there. Then the next thing I'm going to do is I'm going to take the bracket and put it gently on top, and then I'm going to use a screwdriver to tighten it. And you want to be careful here to not put too much pressure on the screw. And then I will get the second servo motor and I'm going to install it into that bracket there. As you can see, I'm trying to make sure that it's going to install carefully and make sure that it's very secured before we move on to our next step. Then I will get the camera bracket, and I'll take off the cap from the VIA Pixetto vision sensor, and then I'll attach that camera bracket onto the servo motor, and then I will use a screwdriver to gently tighten that camera bracket. And there you have it guys, that's it for putting all the components and parts together. So now let's get into our next step. Okay, now we're going to connect the expansion board to the Arduino board via the pin header connectors, and you can see I'm trying to insert it very gently. You have to be careful here, you don't want to damage the pin headers. And as you can see, it's finished. And now that we're finished, let's go into step 2. Okay guys, so here we're at step 2, connecting the 2 servo motor to an Arduino board. So the first lower motor, I'll be connecting that to D7, and then the second upper motor, I'll be connecting that to D8, as you can see that I'm doing right now. And then that's it guys, we've finished with step 2. Now let's go into step 3. Okay, so step 3, connecting the VIA Pixetto to an Arduino board. So the first thing I'll do, I'll connect the first end of the groove cable to the VIA Pixetto, and then I'll take the other end of that and connect it to the UART, which is on the Arduino board. And there you have it guys, we've finished with this step. Now let's go into step 4. Okay guys, so here we're at step 4, configuring the VIA Pixetto. First thing I'll do is connect the micro USB cable on the VIA Pixetto, and then I'll connect the other end to the PC. Then I'll wait for a few seconds for all 3 LED lights to be lit. And once they're lit, now let's get into our next step. Here the Pixetto startup, I'll right click and I'll open it. It will take a few seconds to open up. Okay, it's opened up. Next thing I'll do, I'll go to Pixetto utility. I'll click on it. So now it's opened up. As you can see, I'm already connected to the PC and it's displaying. So now I will configure it by going over to the color detection area. And the color that I want to choose is red. So I'll select red. across the side here. Now I'll select apply, and once I select apply, we're finished. Now I want to test to make sure that my VIA Pixetto vision sensor can detect a red object. So let's test that out, and it works perfectly. Good. Okay, great guys, so now we're finished with that step. Now let's go into our next step. Hi guys, so here we're at step 5, where I'm going to be programming the VIA Pixetto with blocks. First thing, hi guys, so here we're at step 5, where I'm going to be programming the VIA Pixetto with blocks. First thing I'm going to do here is I'm going to open up the VIA Pixetto Junior application, which is here on my desktop. See that? So it's already open. Next, we're going to be using the blocks to program the object tracking device to follow an object. So the first block I'm going to get is from the control category, which is setup. So I'll put this over here. The next block I'm going to get is from the vision category, vision sensor category, and I'm going to slide that over here. So this block here will relate information to the VIA Pixetto vision sensor. So the next thing I'm going to do is I'm going to select pin. I'm going to select here pin 0. I'm going to select here pin 1. The reason why I'm selecting these pins is because I'm opening up a communication between the VIA Pixetto vision sensor and the Arduino board. I'm using pin 0 and pin 1 because these pins are more reliable. Also, RX means to receive and TX means to transmit. So once I'm done with selecting those pins, I'm going to slide that right in the middle over here. And that's the beginning of our first layer of blocks. Next, I'm going to the variable category. Then I'm going to select declare I as integer value. And I'm going to put this here. So in this next part of the first layer of blocks, I'll be creating 4 integers, which are going to control the movement of the servo motor when it detects the object and when it recognizes the object color. The first integer I'm going to be making is the X integer, which is going to be used to determine the center position of the object on the horizontal axis. Then I'm going to create the Y, which is going to be used to determine the center position of the object on the vertical axis. Next, I'll be creating the DX integer, which is going to determine the left and the right location of the object when it's on the horizontal axis position, while the DY is to determine the up and down location of the object when it's on the vertical axis position. So let's start by creating our first integer. It's quite easy. I'll go here, click on make a variable, select X. Okay, so I'm done with that. Slide that right in here. And the same goes for the X. Go over here, click again, a variable. Sorry, we're doing Y, I'm sorry. Press OK. Slide it in here. Next, I'll go back. Get a new one, select, make a variable, dx. Sorry, click dx. Okay, slide it over here. I'm gonna go over here again and then select our variable and the dy. Sorry, y. Click OK. Slide it in here. So we've just created our 4 integers. Next, I'm going to go to the output unit category, and then I'm going to select the block, the rotate the servo motor. I'm going to take 2 of these, and for the first block up here, which is going to be controlling the movement of the first servo motor, I'll set that on pin 7, and then I want it to start at a 90-degree angle. And then for the second one, I'll select pin 8, and I'll select that on a 90-degree angle again. And I'll put them together and I'll slide them right under this block. And basically here we've created both servo motors connection to the Arduino board. And that's it for our first layer of blocks, and now we're going into the second layer of blocks. so for the second layer of blocks, we will create blocks for both servo motors movement to follow the object. First thing I'll do, I'll go to the control category and I'm going to select an if-then block to create an event. And while I'm here, I'm going to minimize it a little bit because the blocks we'll be creating later on will get longer and longer. Once I've selected this block, I'll go to the vision sensor category and I'm going to select detect object is detected and I'm going to slide that inside. Basically, this makes the VIA Pixetto reports that it is detecting an object via a command from the Arduino board. If this condition is true, the block inside will activate that event. Okay, next we will create the blocks to control the movement of both servo motors. We want to make sure that when the VIA Pixetto detects an object, the object tracking device will move vertically and horizontally. To do this, we will create an X and DX section, and then we will create a Y and DY section. So basically, the X section will detect the center position of the object when it's on a horizontal area, while the Y section will make the VIA Pixetto detect the center of an object when it's on a vertical area. Okay guys, so now we're here at the X and DX section. So the first thing I'm going to do is go to the variable category. I'm going to select this block. Once I'm done with this, I'll open up its drop down menu and I'll select X. Put this over here. Next, I'll go over to the math category and I'll select two blocks from here, same block over again, and I'm going to insert them together. This here. So I'm done with that. I'll insert it right here. Next, I'll go over to the vision category section. I'll select object position X, and then I'll select the width. Once I have these selected, I'll put them here inside. Then the first equation I'm going to select here is plus sign, and the next one is a division sign, and then I'll enter a value of 2 to track the center of the object. Once I'm done with this, I'll insert it inside the if-then block. Now let's create a DX integer. So I'll go back to the variable category and I'll select set I to, then I'll open a scrolling menu, its drop down menu, and I'll select DX. Once I've selected DX, I'll go to the math category, then I'll take one block from here and insert it into the block. Now I'm going back to the variable category. I'm going to select this block and I'll put it inside. Here, this. Then I'll open its drop down menu and I'll select X. Once I've selected X, I'll select the equation. It's going to be a minus sign, then I'll insert if t. This makes sure that the detected object is within a position on the horizontal axis so that the Pixetto can recognize and track the object detected. Once I'm finished, I'll insert that underneath this block. So we've just finished with the X and DX integer block, and now I'll show you guys to create the Y and DY integer blocks. Pretty much it's almost the same thing. So first thing I'll do, I'll go back to the variable category right here and I'll take this block. You guys might want to minimize your screen because now we're going to be having more and more blocks. So the first one, again, I'll select Y, then I'll go to the math category and I'll select two of these math blocks. I'll put them together. I'll insert them into this block, and then I'll go to the vision category section and I'll select position Y, and then the only different block here is the height. Then I'll insert those blocks into this block. With the same equation, I'll select plus, and then I'll select a division sign, and I'll select 2 to track the center of the object. Then once I'm finished, I will insert it underneath this block. Next, let's create the DX. I'll go back to the variable category, and I'll select this block. I'll open its drop-down menu, and I'll select DY. I'll go back to the math category, and I'll select this block. I'll insert it. I'll go to the variable category. I'll select this block. I can insert it while I'm here, and I'll open its drop-down menu, and I'll select Y. Then again, change this to minus, and then this one to 50, and I'll insert that underneath this block. This block makes sure the detected object is within a position on the vertical axis. The VIA Pixetto can then recognize and track the detected object. So we've just finished created our 2 section of blocks, which is the DX and X and DY Y. Now let's go into the next section of creating the other blocks. Okay, so now for the DX section, what I'm going to do is I'm going to go over to the control category, and I'm going to select the if then block. For the movement event, and insert it underneath this block. Basically, we're creating a movement event here. Now I'm going to go to the logic category. I'll select this logic block, that here. Next, I'll go to the variable category. I'll select this block. I'll insert it. I'll click on its drop-down menu, and I'll select DX. Then I'll select the less than sign. Once I'm done here, I'll go over to the math category. I'll select this block. So here's my math category block. Then I'll go to the vision sensor category, and then I'll select the object width block. I'll insert it in here. I will select a sign here, which is going to be division sign, and I'm going to insert a value of -2. Once I'm done, I'll insert this block right in here. And then the last thing I'll do, I'll take this whole logic block and insert it in the if then block. So now I'll go to the output unit category. I'll select this block, servo, rotate the servo motor, and I'll put it, just leave it right here. Then I'm going to go to the math category. I'll select this one block, and there's a few things I'll do here. First, I'll select pin 7, and once I've done with pin 7, I'll insert this right in here. And then I'll make sure that this is set on the plus equation. Now I'll go back to the output unit category, and I'll select the angle of the servo motor block. I'm going to move this up a little bit here, and then I'm going to insert it inside of this block here. See, like I said earlier, it's getting longer, so you might want to minimize your screen. Then I'll select, make sure that this is plus, and then select pin 7. Once I've done with this part, I'll go over to the map category, and I'll select map value block. Okay, insert this right here. Now I will go to the variable category, and I'll select this block. I'll open its drop-down menu, and I'll select DX, and then I'll insert that right here. The next thing I'm going to do here is I'm going to set some values. So the first value I'm going to select here is from 0 to minus 50. Then I'll enter 1, 4. To make sure there is a smooth movement of the motor's angle. Then when I'm done, I'll insert this block within the math block that I have here. The last thing I'll do, I'll insert this block inside the if then block. For the next section, I will click on the gear icon of the if then here. Then I'll select else if and I will slide it underneath if. And then you'll clearly see that there's an opening space here. And then this block area, we will start create the next movement event. Okay guys, so for this section that we'll be creating this event, basically we've done it before, so all I will show you guys what to do. An easy way is to right click here, duplicate, sorry, not that one. We want this block section here, duplicate, and there you go, we've duplicated it. Then I will select this greater than sign, and then instead of -2, it will be +2. And once we're finished, I will insert that right in here in the else if section. And there you have it, just created that section of blocks. Okay guys, so for the next section, it's quite easy. We've already created the rotate servo motor block. So basically, we will use the same instruction. You can go back and watch what I did to create this section of blocks. So the easiest way to create this section again is to right click and select duplicate. Once you've selected duplicate, you want to put that down here in the space. And there's a few things that we're going to change. Please keep all the same, the pins. What we're going to change here is the first equation, which is going to be a minus right here. Then the next equation that we want to change is going to be removing the minus from the 50. And it's going to be, that's it, just 50. Once we've finished, I'm just going to insert that right inside the else if block. And we're finished with that section of blocks. Okay guys, so we're here at the DY block section that we will create. So basically it's the same instruction as what I did earlier, creating the DX. There's just a few things that I'm going to change. So the easiest way to do this, I'll first click right here on this section and duplicate the entire section that you can see here. So I'll move this a little bit more or minimize my screen so you can see the few changes that I'll make. So one of the first change I'll make here is the DX. I'll change that to DY, and then I'll do the same here to DY, and then I'll remove the object width. I'll remove that. Then I'll go over to the vision category section and I'll get object height and I'll insert it in that section right here. The next thing I want to, which is very important that I want to remove, is the pin. I'm going to change that to pin 8. So all our pin will be pin 8. So you have to really remember and make sure that you change all these pin, and it's 4 of them that we will change. Next, over closer to the math value section, the first equation that I'll change is minus, and then I'll put this one to a plus sign, and then here we've got to change to dy, and basically that's it. Those are the small changes that we're going to make. Once I'm finished, I can grab this whole section and insert it under this if then section. And there you have it, guys. That's the easiest and the fastest way to do the DY blocks. So guys, so the last block I want to create here is it's a delay timer, and I'm going to go to the control category and I'm going to select the delay block. I'm going to put this here. I'm going to open this up a little bit. Then I'm going to insert 10 milliseconds. Once I'm done here, I'll just put that underneath this block right here. Basically, this will create a time for the motors to respond to a movement, and this will be the end of all our blocks that we were creating. And then we're now going into step 6. Okay guys, so we've already connected the Arduino board to the PC. Now I'll show you guys how to upload the codes to the Arduino board. First thing, we will go over here where it says no hardware, click on its menu and select Arduino Uno. Next to that, it's not connected icon. I'm going to click on that to establish the connection, and I'll select connect. And then here it says go to editor. We want to click on this button. Next, I'll click on the icon next to code to open up the upload section. Then I'll select the button upload, and here you have the codes are being compiled together and uploading. And normally this takes a few seconds, so we could just wait for it. See it, compile success, and it says here at the bottom upload finished. That means your codes have been uploaded. Okay guys, now the last thing I want to show you here is how to save your project. It's quite easy and simple. You go right over here and right next to project, click on this icon and select save project. I have a folder that I created on my desktop called project, so I'll just go there, click on it, and then give it a name close to what your project is. So my project is called object tracking device. That's it. You're done. Click save, and your project is already saved, and you can see the name up here. And yeah, that's the easiest way to save your projects.
Okay guys, now that we've finished assembling the device and uploading the codes, let us do some tests with our object tracking device.